Okay, good. So my presentation is visible to everyone. Please confirm it.
Yes, sir. Visible, sir.
Okay, good. So good evening, everyone. So today, 16th June, and class number 8 and second unit. So today we will complete the second unit. In the previous class, we discussed the following topics. So working principle of the PMSM and working principle of the switch reluctance motors. So we have two types of the motors. Four type of motors. So we are using in the electric vehicle: induction motor, PMSM motor, SRM motor, and BLDC motor. As we discussed in the previous class, we use the BLDC motor for the two-wheeler as well as the three-wheelers, but not use the PMSM because it is a cost. It is not like cost effectively for the case of the two-wheeler as well as three-wheeler. In the four-wheeler in the electric bus, we are using the PMSM as well as the SRM motor, but again that is a depend on the company to company. It is a very company to company, correct? So induction motor normally people use like Tesla's use in the four-wheeler also, correct? So nowadays people are no more use the induction motor, but most of the company use the PMSM, BLDC, and SRM motors. So is there any confusion, any query from the previous class? So working principle of the BLDC and PMSM motor. Again, I am repeating. So control of the electric motors, it is a separate subject. So it is a, we can say, the fundamental of electric drives. But I am covering this one because it is a part of electric vehicle, and you should know about the which type of motor it is used. So that's why I'm not covering the detailed modeling part as well as the controlling part of the particular motor. Correct. So it will take around like 10 to 12 lectures. So suppose we want to cover the like details modeling as well as the like controlling of the each and every motor, correct? So it is a separate subject. Okay, so suppose you are doing the project for the particular PMSA motor, SRM motor, या induction motor, या BLDC motor. So you have to go through the like detailed modeling as well as the control structure. Okay, so in the project structure, suppose you are facing the any issue with the modeling as well as the controlling part for this particular motor, then please let me know. So I will discuss with you. So in the with you individual, not in the class, correct? Then maybe you will get the knowledge. Okay. But as of now, for this subject, it is not a part of the syllabus. That is a detailed mathematical modeling. Just overview of the operation and working principle as well as the advantage and disadvantage. That is a part of the application. Okay. So is there any confusion? Is there any query from the previous class? Okay. So last topic of the second unit, remaining two topics. So today we are going to discuss. So first one, there is a selection of the electric motors for the EV application, correct? How we can select electric motors, correct? So maybe the PMSM, maybe the BLDC, maybe the induction, yeah, maybe the SRM motor. So which type of motor we have to select for the particular our application, correct? Maybe the two-wheeler, maybe the three-wheeler, yeah, maybe the big vehicle, correct? And last one, there is a overall control strategy of the electric motor. So how many control strategies available, correct? In the first semester, I already discussed in the analysis of the electric motor subject, correct? Modeling and analysis, I think, in the first semester. I already discussed about the detailed analysis as well as modeling part, correct? But not like PMSM, BLDC, and SRA motor. I covered the induction motor as well as the DC motor, correct? So here today we are going to see the overall control strategy as well as the selection of the electric motors. So what type of parameter we have to consider while selection of the electric motors. So we have to consider the multiple parameters while selection of the electric motors. So first one is a performance requirement. So which type of performance you are going to take care, correct? So performance means we have to consider the electrical parameters as well as the mechanical parameter, correct? So electrical parameter we can say power rating. So power rating of the motor. So both power rating mechanical as well as the electrical, because we have to see the electrical power as well as the mechanical power. In the case of the electric motor, we have to consider the mechanical power. But how much input power we have to give, that is your electrical power, correct? So input of the electric motor, that is electrical power, and output of the motor, that is your mechanical power. So that's why we have to consider the both power, mechanical as well as the electrical. So first parameter, it is a power rating, that is a most important parameter, correct? So first question is a power rating. So determine the continuous and peak power needs based on the vehicle weight, diesel acceleration, and the torque speed. So you can see we have to consider the peak power as well as the continuous power. So both power is different. One is a peak power, that is like maximum power it is required, and continuous power, so from the starting to end power. So two power we have to consider, correct? So continuous power and peak power on base of both parameters. So on base on the vehicle weight. So what is a vehicle weight? Second one is the desired acceleration. So what is your desired acceleration? And third one is a top speed. What is your top speed? So these three parameters we have to consider while considering of the power rating, that is like mechanical as well as the electrical power rating. Okay. But yes, student, you have to consider the continuous power as well as the peak power. Okay, not single power. Both parameter you have to consider. Second one, that is a torque speed characteristic. That is the most important. Okay, so considering the starting torque and top speed profile, constant torque versus the constant power region. In the previous class, we discussed the like different torque speed characteristic for the four type of motor: induction motor, BLDC, PMSM, and SRM motor. Correct. So now you have a clear idea. So which type of torque speed characteristic we have to take care in the particular speed range, maybe the like dynamic speed range, maybe the constant speed range. So second parameter, there is a torque speed characteristic. Third one, that is your speed range. So match the motor speed capabilities to the vehicle requirement. Typically, maybe the 0 to 10,000 RPM for the EV. Correct. So we have to consider the maximum speed range, and then we can say yes. Suppose we have an induction motor. So is it possible it is operate like maximum speed? Maybe that is a 10,000 RPM, maybe the 1,000 RPM, yeah, maybe the 2,000 RPM. Correct. So because every motors have a few limitation. So we have to consider this parameter. There is a performance requirements. So this slide, it is the most important: power rating, torque characteristic, and the speed range. Okay. Is there any confusion for this slide? Any doubts? Any confusion? Okay. Second one is a motor types comparison. So in the previous class, we discussed these four type motors. So there is one first one, there is a PMSM, AC induction motor, SRM motor, and BLDC. We also discussed the DC motor, but nowadays there is a no more use in the DC motor. So we can say DC motor there is a replace with the BLDC motor. Okay. So advantage, disadvantage, and typically EV application. So we can say PMSA motor typically high efficiency, there is a 90 to 95% efficiency, high power density, and excellent control. Yes, control complexity is a very difficult, because this is the like three phase quantity. We have to control the three phase quantity. Instead of the BLDC motor, there is a control is a very simple. Disadvantage, there is a expensive because of the large earth magnet, permanent magnet. Again, disadvantage, demagnetization risk at the high temperature. Suppose your motor is continue rotating, continue operate, so continue heating. So at the like few degree, maybe the like 55 degree or maybe the 65 degree, demagnetization effect happen. So my motor is lose the like permanent magnet density. Okay, so there is a demagnetization effect. Typically application most modern EVs, correct? Tesla's, Nissan. So most of the company use this PMSM motor. What about the AC induction motor? rugged, no permanent magnet, and low cost. Yes, we already know that induction motor is a rough and tough use, correct? But disadvantage is a lower efficiency at partial load and larger size. So size is large as well as the lower efficiency. Tesla's use the induction motor and some commercial EVs use the induction motor. Okay, but in Tesla's use in S3 model, S3 four-wheeler vehicle use the induction motor. SRM motor, there is a switch reluctance motor, simple construction, fault tolerant and wide speed range operation. Why wide speed? Because we can operate this motor by power electronic switchings, correct? But disadvantage, there is a noisy, complex control because there is a operate with a power electronic switch and high torque ripple. Some industry use the SRM motor. There is like niche application, heavy vehicles. That is a use the like SRM motor. BLDC motor, it is the same like the PMSM. Simple control because here at a time we operate the only two phase. That's very simple control. Good efficiency. PMSM and BLDC both are the very good efficiency motor. Limited to high speed performance, so there is a disadvantage for the BLDC motor and cogging torque. Low cost EV company use e-bike and small vehicle. So these are the typical comparison while selection of the motor, correct? So we have to take care about this advantage, disadvantage of the motor for the selection of the electric motor. Third one, consideration efficiency. We have to consider the efficiency. So look for the motor with greater than 90% efficiency across the operating range. Yes, we must consider the efficiency is high efficiency, correct? Not like below 80% and 85%. We have to take care about the more than 90% efficiency across the all operating region. All operating region means constant speed, constant power, constant torque, dynamic torque, correct? So every reason we have to get the like more than 95% efficiency and 90% efficiency. Consider the partial load efficiency important for the real world driving, correct? So we have to consider the real drive application and then we have to consider the like efficiency. Evaluate the regenerative braking capability. Yes, also we have to consider the regenerative braking efficiency. Yes, again, this topic is a very good. So for your project work, so regenerative braking for the PMSM, BLDC, SRM, and PMSM motor. Correct. So this is a very good and hot topic. While discussion of the regenerative braking, I also told. So maybe you can consider this topic for your project work. Correct. So this is a very good topic for your project work also. Thermal management. Again, there is a very good topic, but thermal management again there is a part of the mechanical work, but still you are interested in the thermal management, then you can consider also thermal management for your project work. So thermal management, we have to assess the cooling requirements. So ultimately we have to take care about the cooling for the motor as well as the battery, correct? So there is a air cooling, liquid cooling. So many types of coolings are there, but that cooling system, it is a not part of the like electrical engineering, correct? But it is a deal with the, like mechanical engineering people, correct? But your interest is very good, then you can also consider this topic. Consider the temperature derating effect on the performance. Evaluate the thermal protection system. Okay, so this is the thermal management system we have to consider also. Integration factor, yes, how you can integrate with the motor, with the battery, motor with the gear system, motor with the transmission system. So integration factor, there is a physical dimensional package constant in the vehicle design. Yes, we have to consider the vehicle design body also, we have to consider the vehicle mass also. So we have to consider the like light electric motors, it is a not like heavy electric motor. Weight, yes, affects the overall vehicle efficiency. Suppose your motor weight is a very high, then it is added the overall mass of the vehicle, correct? Suppose your mass of the vehicle is high, then it will reduce the efficiency of your vehicle. Okay. Mounting requirement, compatibility with the transmission and drivetrain. Yes, so where we have to mount our motor, correct? Maybe the center of the motor, maybe the hub motor, yeah, where. So it is ultimately the compatibility with the transmission and drivetrain. So integration factor, it is the most important part. Control system complexity. So match motor type with the available control expertise. So we have to choose the control algorithm. We have to choose the control system that is available in the market. Correct? It is not like that. So we can propose the like new control algorithm, then we can test in our vehicle. Correct? So propose algorithm that is your based on the your R&D work. It is not like commercial. Correct? Consider the sensor requirement. There is an encoder approximately, yeah, which type of sensor you are used to control the speed of the motor. Correct? Evaluate the control algorithm. So which type of control algorithm you are used? Maybe the director control algorithm, maybe the sensorless algorithm, maybe the like AI based algorithm. Which type of control algorithm you are used for the controlling of the your motor. So to in the today's class we are see the control algorithm, correct? Various type of control algorithm, and that is your last topic of this unit. Okay. And define the vehicle requirements. So there is a which type of vehicle, maybe there is a commercial vehicle, maybe there is your personal vehicle. So we can say the passenger car, bus, truck. So which type of motor you have, which type of vehicle you have to use for the selection of the motor. Performance target, there is maybe the 0 to 16 meter per hours time. Okay. And gradability, so which road condition you are considering, correct? So there is a mile per hours, so 0 to 60 mile per hours. And which type of gradability? So gradability, it means that is like plain road, yeah, maybe that is a hilly road. So that parameter we have to consider, because suppose you are drive your vehicle most of the time like hilly area, like in Nepal I can consider the Kathmandu. Otherwise in the India, suppose I can consider the Himachal Pradesh, so there is a hilly area. Then we have to consider this parameter, and that is a most important parameter. Range requirements and operating environment, that is a temperature and terrain, correct? Because temperature, that is a most efficient most important parameter. Suppose your temperature is a 0 to maybe the 45 degree, then it's a normal temperature. Above 45 degree, that is a like very hot temperature. But in the consider the Nepal Kathmandu temperature, there is like maybe the 0 to maximum is a 40 degree, because that is like cool area. Maybe the nowadays around like 35 to 40 degrees. So what is the current temperature? 35, around like 35 degree
Maximum temperature about 30 to 33 degrees, sir.
maximum, correct? So it is
Yes.
like not hot area, it is like cool area, correct? So no need to, so don't worry about the like while design the like motor, but ultimately we have to consider the motor temperature, we have to ultimately consider the environment temperature while considering the electric motor. Okay. Then calculate the power needs. So this already we discussed, so and we already solved the numerical, so we have to calculate the power. Okay, so this one is a formula for your just information, correct? So we will see one numerical based on this formula. Okay. So which type of motor you have to use? So there is a premium EV, so maybe the PMSM BLDC. So PMSM, cost sensitive application, AC induction motor, otherwise the BLDC motor, and heavy duty application, SRM motor, otherwise high torque PMSM motor. So you can see, so we have a total four type of motor. So premium AV application, mostly we can use the PMSM and PMSM motor. Cost sensitive application, we can use the AC induction motor, otherwise the BLDC motor. And heavy duty application, SRM motor, otherwise the high torque PMSM motor. Specify motor parameters, so continuous and peak power rating, maximum speed, voltage rating, So there is a typically 300 to 800 volt for the EV application, and torque speed characteristics. So mainly these four parameters we have to consider for the specify the motor parameter. Okay. And this one is like evaluate like necessary the system. So there is a cooling system requirement. So which type of cooling, gear reduction needed. So mostly use the single gear transmission system, as I said in the previous classes. And power electronics compatibility. So which type of power electronics module you are used to operate the electric motors. Okay. So this type of parameter also we have to considering while selection of the electric motors. So emerging trends, so integration of motors, reduction units. So combining the motor with the fixed gear ratio, correct? Again, there is only single gear ratio. In-wheel motor vehicles, so direct drive the solution through the wheel, unspurred the mass challenges. So normally we use the in-wheel motor, and there is a hub motor, correct? So you can see in the two-wheeler as well as the three-wheeler, they are using the hub motor, as well as the three four wheeler and the electric bus, they are using the like multiple motors. So maybe you have a four wheel, so normally people use the like two motors, so one motor in the front wheel and another motor on the back wheel, correct? So rail wheel and the front wheel, so depend on the your power rating, we can use even on the every wheel we can use the motor, correct? High speed motor, so maybe the more than 1500 15,000 rpm design with the reduction gearing. And advanced materials, so high temperature magnet, improve the winding technologies, correct? So suppose is there any impact, suppose you are considering the temperature effect, so we have to consider the like different type of winding materials, correct, as well as the high temperature magnets. So these are the like emerging trends. So we have to consider the parameters by considering the electric motors. So practical consideration. So first one is the cost. That is the most important thing. So PMSA motor are typically 20 to 30% more expensive than the induction motor as well as the BLDC motor. Okay. Supply chain, so there is a rare earth magnet availability for the PMSM, so from where you are getting the like raw material. Serviceability, some motors are more field serviceable than the other, correct? So it is not like that, so every month you have to do the service for the electric motor. It is not acceptable for the people, correct? So yes, so regular service maybe the like every 6 month, yeah, maybe the 1,000 kilometer, yeah, maybe the 2,000 kilometer, correct? But it is not like that. So every month you have to do the service. Noise and vibration important for the passenger comfort, correct? Yes, nobody want like high noise and vibration vehicle, correct? Even suppose you are going to buy the ceiling fan, then you can say like noise is very less, correct? So this is the your electric vehicle, correct? So we have to sit and we have to drive. Suppose it is a too much noisy, too much vibration, then nobody will buy the vehicle. Okay, so there is again noise and vibration. Okay, so yes, noise and vibration, again there is your project topic, so you can also consider this reduction of noise and vibration. Even my PhD topic was on the reduction of acoustic noise and vibration for the like EV application. So you can target the noise and vibration in the power electronic side, it is a not like mechanical side. Yes, you can target the mechanical if you are interested. Otherwise, this noise and vibration also good topic for your research work. Yes. So any confusion till now? Any confusion? Then we are considering the one practical application and for selection of the electric vehicle. If you have no doubts, no confusion till now, then we move ahead. So practical example, motor selection for the compact urban EV, correct? So we can consider the one example and then we can select the final which motor we have to select. Okay. So yes, so we have a particular some parameters. So suppose we can consider as customer demand. So customer demand is a type 4 seater vehicle, urban commuter electric vehicle, uh, car weight, otherwise curb weight, there is a 20 100 kilogram including the battery. So overall, your vehicle weight there is a 200 1200 kilogram. Target performance 0 to 600 0 to 60 kilometer per hour less than 8 seconds. Okay, top speed 120 kilometer per hour, so there is a practical range. Gradability 20% at 60 kilometer per hour. Battery system, there is a 350 volt nominal voltage, and range target there is a 250 kilometer NEDC cycle. So driving cycle we already discussed in the previous class, I think before the two class. So this type of practical parameter we got from the customer, correct? And our target is we have to consider the electric motor, which type of motor we have to select. Maybe the induction, BLDC, PMSM, yeah, SRM motor, correct? So we have to calculate all the parameter power, and finally we have to say yes, how much power rating is required for the motor. Maybe the 200 kilovolt, maybe the 300 kilowatts. Yeah, which type of power, correct? So this is the numerical parameters. So we got from the customer, and now we, as a electrical engineer, we have to select the like electric motors, correct? So one by one, we can solve this numerical step-by-step process. So first step, there is a power requirement calculation. Yes, there is a one of the most parameter. So what is the power rating of this electric motor? Correct. So there is a tractive effort components at 60 kilometer per hours. Correct. So because customer demand is a 60 kilometer per hours, so we are considering the 60 kilometer per hour. So you can see maximum kilometer is 60 kilometer per hours. Yes, so we are considering the tractive effective components as a 60 kilometer per hours. So suppose you are converting into meter per second. So this is the 16.67 meter per second. Okay. So there is a 60 kilometer per hours. So now next we have to calculate the like all the parameters. So let's see, we can calculate all the parameter one by one. So just 1 minute. So I already calculated. So just 1 minute. Yeah, so first we have to calculate the rolling register force. Rolling register force. So first parameter we have to calculate the rolling register force. So this is the FR. Sometime maybe use the capital R, and sometime maybe the small r, but there is a rolling register force. So rolling register force, that is a FR is equal to mu r into mass into gravitation. So mu r we can assume there is a 0.015, correct? So we can assume there is a 0.015. It is a not given in the from the customer side, correct? So we can consider there is a 0.015 because maximum value of the mu r there is a 1, correct? And mass is given there is a 1200 kilogram, and gravitation there is a 9.81. So what is the value FR? So you can just multiply FR 0.015 into 1200 into 9.81. So as per my calculation, there is a 1.176.6 Newton. So maybe somebody can do the calculation, okay? And please verify this answer. So 0.015 into 1200 into 9.81. So I got 176 Newton, correct? Second parameter we have to consider, that is like aerodynamics, drag force, aerodynamics, drag force, FA. So FA is nothing but 1 by 2 into rho into CA, there is a drag coefficient, into area into velocity square, correct? So 1 by 2 rho CA, there is a drag coefficient and area into velocity square. So 1 by 2 rho is not given in the question, so we can consider rho value, that is like 1.225 1.225 kilogram per meter cube. Into CA, there is a drag constant, we can consider the 0.3. Area is a 2.2, and velocity is given, there is a 60 kilometer per hour, so we have to convert into meter per second square, correct? So that is your 16.67, correct? So FA is what? FA is equal to, as per my calculation, 112.3 Newton, correct? So this one is FA. Now we have to calculate the gradient resistor. Third parameter we have to GRA, gradient resistance. And in the question it is a given like 20%, correct? So gradient resistor force, correct? So third parameter we can say the gradient resistance force at 20 percentage. So gradient resistance force we can indicate by Fg is equal to m into g into sine theta. Mass is given, there is a 1200. Gravitation is given, there is a 9.81. Theta is given, so sine theta 20%. So there is your 0.196. So here is Fg is equal to, as per the my calculation, to 2310 Newton. 2310 Newtons, correct? Fourth one, there is a acceleration. Acceleration, there is like 0 to 60 kilometers per hour for 8 seconds. Okay, so we can calculate acceleration A equal to delta V upon delta T. So velocity upon time, correct? So delta V velocity, there is like 16.67, because 60 kilometer per hours divided by time, there is 8 second. So is equal to 2.08 meter per second square. And we can say the Fm, m into A, m is given, that is a 1200, and A, there is a 2.08. So is equal to 25 Newton, 2500 Newton. Okay, so this is your acceleration. Now finally we have to see the your tractive force, peak force, correct? Otherwise we can see the power rating.
Sir,
So
inclination is considered what angle, sir?
uh, that is like 20 degree, I think so. Just 1 minute. So you can calculate. So because here theta, sine theta is a 0.196. So currently I don't have like scientific calculator. So you can see sine theta is a 0.196. So what is the value of theta? Just 1 minute. I can try for my mobile. So sine, just 1 minute. Sine inverse option is not available in my calculator. So do you have a calculator, scientific calculator? Just 1 minute. 11 degree. So sine 11, I think
0.19, sir.
yeah. So there is a 11 degree inclination angle. That is a theta is equal to 11 degree. So here I assume that is a theta value. That is a 11 degree, correct? So that is a 0.196. Got it? Because this type of parameter we cannot get from the customer, because even customer don't know about the like what is the inclined angle. So as an engineer we can select the like inclination angle, so based on the like normal parameter. Okay. Yeah. So next one, peak peak tractive force. So peak tractive force is nothing but we have to add the all the power. So this is the Fr, rolling resistor force, Fg, gradient force plus Fm. So all the power we calculated. So Fg 176.6 plus Fg 112.3 plus Fm. Fg plus Fa is missing. Just 1 minute. Fr plus Fa plus Fg plus Fm. So Fr is equal to 176.6, Fa 112.3 plus Fg 2310 plus Fm 2500. 176, 112, 2310, and 25. Yes. So TR, there is a 5100. Yes. So this is the attractive force. So now finally we have to calculate the power, because ultimately we have to find out the power rating, correct? So power is what? So power is equal to Ft. So yet, so this is the Ft, correct? So this is the Ft, attractive force into the velocity. So attractive force, that is a 100 into velocity, there is log 60.67. So power is equal to what? Power is equal to 85 kilowatt. So you can see there is a electrical power, it is required the 85 kilowatt hour. Okay. So next one we have to calculate the uh, so this one is 8 wheel, correct? So power calculation 8 wheel. What about the continuous power requirement? Continuous power requirement. So there is again continuous power requirement. You can consider the same process for the maybe the 100 kilometer per hour, correct? So same process we have to consider. Same process we have to repeat, correct? Efficiency. Efficiency. We have to calculate the efficiency. Efficiency is what? Motor power required. So how much power? 85 kilowatt. 85 divided by the efficiency. I think the question is given efficiency. Efficiency is not given, so we can consider the 90% efficiency. So that is 90%. Assume 90% efficiency, correct? So 85 divided by zero point 0.9 is equal to 95 kilowatt. So that is your peak power. Okay, so this is your peak power. There is a 95% kilowatt. Okay, so now we have this type of formula available with this type of writings available. So finally we have to consider the motor type of selection. So we can compare the PMSM and the induction motor. We are not consider the BLDC motor as well as the SRM motor. Why? Because SRM motor it is a very complex as well as the very like based on this parameter it is a very costly. We have this type of power, so compared to this power and compared to different type of motor, so we have a suitable motor selection. It is a PMSM as well as the induction motor. So we have a two motor. So from this two motor, which motor we have to consider? So suppose we can consider the model. There is a Bong One NV250. So this is the manufacturing of the manufacturer of the motor, and second one is a Tesla small drive unit. Correct. So peak power there is 100 kilowatt and one 10 kilowatt. Continuous power 50 kilowatt and one is 45 kilowatt. Peak torque, there is a 280 Newton meters, and the induction motor 240 Newton meter. Maximum speed is a 1200 RPM, and here is a 10,000 RPM. Efficiency, there is a 94 to 96%, and here efficiency induction motor 89 to 92%. Cooling, in the both case, there is a liquid cooling. Weight, we can say 48 kilogram for the PMSM, and induction motor there is a 55 kilogram. Cost, maybe the between to 1200 to 1500 US dollar. And in the case of the induction motor, there is a 900 to 1100 US dollar. So based on this parameter, anybody can say which type of motor we have to select. So we already calculate the like power, torque, and RPM. So suppose you are a R&D engineer and you want to select the motor. So which type of motor you are targeting? Induction motor, yeah, PMSM motor. So yes, student. Any idea? Any comments?
Induction motor, sir.
Which one?
Induction.
Induction. Based on your opinion, maybe the induction. Yes. Any other opinion? Yes, from any other student? Yes, Sanjeev.
Yes, sir.
Which type of motor you are select?
I think I have to select BMSM motor, sir.
Okay. Sabin, are you there?
Yes, sir.
Yeah, which type of motor you are selecting for this requirement?
PMSM, sir.
PMSM, okay. Yes, Sai Susma. Susma is there, correct? Are you there? Okay, Niroj, are you there?
Yes, sir.
Yeah,
Yes, sir.
which type of motor you are select for this application?
Can you repeat the question, sir?
So we have to decide the motor, correct, based on the requirements. So we calculate the motor parameter and other parameter. So which type of motor you are selecting?
From these motors, sir? PM,
Yes,
PS, PMSM, and induction.
PMSM and BLC motor. Okay. So selection requirements. So finally we have to select the PMSM. Why? Because higher efficiency. First one is a higher efficiency. Improve the range. Better power density. Fits the compact packaging. Correct. Superior partial load efficiency. Match urban driving cycle. 5 to 7% range advantage outweigh 20% cost premium, and smoother operation for the passenger comfort. So that's why we have to select the PMSM. And why not the induction motor? Because lower efficiency reduce the achievable range, large size packaging in the small weight, higher thermal load in stop and go traffic. So because of these three reasons, we are not selecting the induction motor, and because of this reason, we are going to select the PMSA motor for this particular application. Correct. So based on this parameter, we have to select the which type of motor is better. Maybe the PMSM, or maybe the induction motor. Okay. Correct. So this one is a last. This one is numerical for the practical consideration of the electric motors. Is there any confusion, any doubts? So how we can select the motor for our electric vehicle application? Any confusion, any doubts? If no confusion, then we start the last topic.
Sir, cost
Yes.
does not matter. First selection basis on the efficiency and other parameters, but cost is not considered.
No, because cost you can see here is only 1200 US dollar to the 1500 US dollar for the PMSM. In induction motor, there is a 900 to the 1100, correct? So you can see around like 500 US dollar is a difference, correct? Suppose on an average you can consider maybe the minimum is a 900 in the case of the induction motor, and the PMSM there is a 1200. So you can see 400 US dollar there is a difference, correct? And maximum there is a 1500, and here is a 1100. So around 400 US dollar is difference between the PMSM and BLDC motor. But compared to that, you can see continuous power rating, we will get the 50 kilowatt hours in the case of the PMSM. But in the case of the induction motor, there is a 4500. Peak torque, here you will get the 280 Newton meter, but here you will get the 240 Newton meter. Even RPM, you will get like 1200 RPM. But in the induction motor, you will get like 10,000 RPM. Efficiency maximum you will get the 96, but here you will get the 92% efficiency. Even weight 48 kilogram, and here is weight 55 kilogram. So around 6 kilogram weight you will add. Suppose you are selecting the induction motor. So you can see, suppose you want to save the amount that is only like 400 US dollar. So additionally, you will add the weight, reduce the efficiency. Also, you will not get the more load, even more power, correct? So sometimes we have to compromise with the this type of parameter, correct? So suppose you want to reduce the like amount is a 400 US dollar, and this amount is a initial cost only, correct? So suppose you want to like cheat with the customer, then you can select the induction motor. So you can save the 400 US dollars. So it is around like you can say the 80,000 Nepali rupees, correct? In Indian rupees is around like 40,000 rupees. But initially that amount you can save, but during the like running condition, it will affect on the regular maintenance and everything. So that's why cost is a not a consider as a for this numerical. Suppose that cost is maybe the 1000 US dollar or 2000 US dollar, then we have to do the more analysis. Okay. So as of now, for this numerical cost difference is only like 400 US dollar. It is not too much. Got it?
Yes, sir.
Okay. Any more confusion? Any more doubts? Yeah. So final selection is index PMSM motor and rejected the induction motor. So suppose I will give this type of numerical in the example in the exam, then you have to mention the reason, which type of motor you are selecting and why, and which type of motor you are rejecting and why. Okay. So that type of answer I will accept. I will expect from you. Okay. Now last topic, that is a control strategy of the electric motor. Yes, so unit name is a control of the electric vehicle. So we already seen the like overall working principle and the advantage disadvantage of the motor selection as well as the motor. So final one is a control strategy. So which type of control strategy we have to select? So first one is a fundamental control strategy. So maybe you know about the fundamental, there is a scalar control. So you all of you know about the scalar control. There is a variable frequency. Uh, uh, Sorry, we have to maintain the voltage and frequency constant. So V by F control method. Maintain the constant voltage to frequency ratio. There is a principle. And characteristic, we can say the simple implementation, open loop operation, poor dynamic response, no direct torque control. So these are the characteristic for the V by F control method. So still people use the V by F control method in the industry for the induction motor only. Okay, for induction motor only. Not for any other motor, correct? Based for the basic application where the cost is a critical, performance demand are very low, correct? So then we can use the scalar control, okay? And there is a vector control. Now how scalar control is operate, it is not the part of this syllabus, correct? it is your part of the project work, correct? So I will not ask the like you can explain the vector control diagram, correct? Vector control, field oriented control. So I will not ask for the scalar control diagram, correct, in the exam, but I will ask the detail about the vector control operation and with the block diagram, correct? So you have to see the block diagram of vector control, and I already covered this vector control diagram in the first semester analysis of the electric motor, correct? So you can just revise that concept. So how vector control is operate. So basic principle, that is a decouple the torque and the flux components. So we can say we have to decouple the both the component. There is a vector quantity. So we can say suppose on the x-axis maybe the torque, on the y-axis maybe the flux, correct? And we have to control the both quantity individual, that is a decouple the torque and flux component, and then we can do the speed and the torque control. Implementation, Park and the Clark transformation. Yes, so you have alpha beta ABC dq quantity. So we have a alpha beta dq quantity and ABC quantity, correct? So Park and Clark transformation convert three phase to dq coordinate. Independent the control of the torque, that is a q axis and du axis. So q axis, that is a torque control, and d axis, that is a flux control normally we use. So there is a q axis, that is a torque, and d axis, that is a flux. Required the rotor position feedback, so maybe the encoder and resolver. Okay, so normally this type of parameter we are considering for the vector control and especially for the field oriented control. Advantage, there is a precise torque control, fast dynamic response, and high efficiency. So that's why normally people use the FOC to control the speed and torque of the motor. Variants, different type of variants available. So there is a rotor flux oriented control, stator flux oriented control, and direct flux control. So we have a both flux, stator flux as well as rotor flux. Maybe you can consider any one type of flux, and then you can control the your motor. Okay. Direct torque control method also. So directly control the torque. There is a flux without the modulation. Characteristic, no coordinator transformation needed. Very fast torque response, less than the 100 microsecond. Use hysteresis controller and higher torque ripple than the FOC. Modern improvement, space vector modulation. So you can use the space vector modulation techniques to control the direct torque control method, and model predictive direct torque control. Okay, so this type of different control algorithms are there to control the speed of your motor. Okay, advanced control strategy, there is a model predictive control. Okay, approach, use the systematic model to predict the future behavior. So we have to analysis the model, so detailed models of your motor, and then we have to predict the future behavior. So which type of, so there is a types is a finite control set, MPC, there is a model predictive control. Continuous control set, so we can say CCS, MPC. Advantage, handle the multiple constant, optimize the multiple objectives, and excellence dynamic performance. Yes, system is a very complex, so but we will get the like good result. Challenge is high computation load, because we have to do the finite control algorithm, we have to consider the many models, correct? Many subsystem we have to consider, so there is a high computation load. Required an accurate system model. Yes, this is the very good for the accurate result, but it is take the high accurate high computation time demand, correct? Sensorless control algorithm, there is also possible. So there is a like back EMF based sliding mode observer. SMO is nothing but sliding and Labzard observer, high frequency signal injection, model reference adaptive system. So I have a research paper on this method, that is a sensorless, because it was the part of my PhD work. So I returned the research paper in MRAS as well as the sliding mode observer. So you can see my paper if you want to do the implementation of the sensorless control algorithm, maybe the for your project work, correct? Application: elimination of the position sensor, reduce the cost and improve the reliability, and work well in the medium as well as the high speed operation, correct? So people maybe use the sensorless operation, and nowadays many company use the sensorless operation also. So emerging techniques, so latest techniques people are going to use, that is a AI base. So nowadays people are talking about the artificial intelligence technique, neural network, reinforced learning, fuzzy logic controller, there is a non-linear system, correct? So nowadays people talking about the AI, and there is a very good techniques. Fault tolerant control, so post fault tolerant operation. So as I said in the beginning of the this subject, so latest hot topic, that is a, we have to do the research on the like condition monitoring and fault diagnosis, correct? Reconfiguration algorithm, health monitoring integration. So we have to consider all type of parameter while controlling of the your motor, correct? So is it you are considering this type of parameter for your control algorithm? So suppose fault is happening, then you are going to consider this type of parameter for your control algorithm, correct? So suppose fault is happening, still your motor is operating in the safe zone, yes or no, correct? So we have to consider this type of parameters also: fault, post fault operation, as well as the reconfiguration algorithm and health monitoring integration. So key point from the today's class: selection of the EV motors for the electric application and control strategy of the electric motors. So if you have any question from the today's class, then please let me know so we can discuss before the closing of this class. Key point from the next class. So in the next class, we are going to start the third unit. There is a battery, and there is a most important part, because battery is the heart of the electric motor. Okay, and second heart is a your motor. So we can say in the electric vehicle we have a two heart. One is a battery, and second one is your motor. Correct. So motor we already discussed in the second unit, and now we are going to discuss from the next class, that is a battery. Okay. So we can start with the introduction of battery. What is a battery? Various type of batteries, parameters, battery life and safety impact. So maybe then the third class, yeah, fourth class, one of the student asked me the question, how we can calculate the continuous charging currents, how we can select the battery. So all the questions I will cover in this unit. There is a third unit, and it will take around like 20 hours, correct? Around 80 to 20 hours lecture, correct? So most important units, that is the battery. Okay. So I will cover those questions in this class. Okay. So thank you so much for the today's class. From the next class, we will discuss the third unit. Okay. So these are the references. Still, you are using these references for the this lecture notes. Okay. So thank you so much for your attention. If you have any question, then please ask me so we can discuss. Otherwise, we can close this class.
Thank you, sir. Thank you.
Thank you so much, and best of luck for your presentation.